Okay, I'm going to start off saying that this is my function. I'll list the counted rational roots. They're going to be long. And what do you get? The factors of 48 divided by factors of 1. And it's really bad. So you get 1, 2, 3, 4, 6, 8, 12, 16. Wow, it's a long list. 24 and 48. All right. Now, I got to be honest with you. Trying to get through that long list is probably not a good idea. I think start easy and move your way through it. All right. Start easy and move your way through it. So, kind of looking at it, the candidate rational roots, I would start with 1. And 1 just doesn't cut it. Right. You get 1 minus 5 minus 8. There's no way. Minus 1's not going to cut it either. Then you go on to 2. A little more challenging for me. You get 8 minus 20 minus 6. That's not going to cut it either. All right? Minus 2 is not going to cut it. Now, of course, now I'm getting into that region where things are looking a little bit tough. But I'm looking at it, and I'm starting to think that positive 3, that's 27. Nah, it's not going to work. There's no way you get a 0. But the f of minus 3, I'm thinking this is probably the first one I'm having some level of confidence. Let's take a look at, what do you get? Minus 27 minus 45 plus 8 plus 48. Well, kind of looking at it, minus 27 minus 45, that's what? Did I do that right? 9 minus 27. Oh, you know what? I'm sorry. Made a mistake there in the arithmetic. That's going to be 24. Sorry about that. And what do you get over here? Well, I'm going to add these two together. That's minus 52, 62, 72. And I'll add these two numbers together. What does that give you? 48, 52, 72. Bingo. Found it. What do I get over here? Well, if minus 3 is a root, the factor must be x plus 3. All right? Now, I'm going to start to erase my work because I don't need it anymore. I got to be honest with you. I don't need those rational roots anymore because the reason for that is even if there's one more in there, it doesn't matter to me. What I'm going to say is I'm going to look for a long division. I find it so much easier than doing arithmetic and going through that list. All right? But let's take a look. Let's write this down. What do you get? X plus 3. I'll divide it into this cubic, and I'll get a quadratic, which is much easier for me to deal with. This is going to go smoothly, and there'll be a remainder of 0. So what do you get? X squared. That gives you x cubed plus 3x squared. Subtract, that's minus 8x squared, minus 8x. Oh, I forgot to drop my places down. What does that give you? Minus 8x squared. Let's see, minus 24x. Let's see, we got to subtract, right? That's going to give me what? 16x plus 48. And then I got to do it again, right? So it's going to be plus 16. What do you get? 16x plus 48. 0. So I know the other factor now. What is it? X squared minus 8x plus 16. And let me repeat this. Quadratics are so much easier to deal with. Now, granted, if it's factor with my fingers, I'm going to do it. If not, I'm not going to go anywhere near it. Now, does this factor? Yes, it factors. And what do you factor to? It's going to have one of those rational roots in it, by the way. This is x plus 3. And then you're going to get x minus 4, x minus 4. Now, again, are they in the list? Yeah, minus 3 is in the list, and 4 is in the list. 4 is a repeated root, all right? So I'm going to claim that we're done here. I listed the candidate rational roots. Which ones would work? Minus 3 would work, and 4 would work, all right? What did I stumble upon, though? Well, I start low. Minus 3 stumbled on that. It gives me a 0. And then I used long division to find the remaining factor. And the remaining factor was x squared minus 8x plus 16. And then I use trial and error, or just simply by inspection to factor that, and I get the same result. All right? Thank you.